Okay, so in this video, I'm just going to go through a few examples of how to find an antiderivative so that you can use that to complete your prequel. So none of these examples are going to be the same ones that are on your sheet, but they are similar enough that you should be able to use them as a reference. So I'm going to start looking at example 1. If you want to do this on your paper, you can either do it on the back or there should be some extra room, or you can do it on a separate sheet. So remember, we're being given the derivative when we're trying to find the original function. So let's think of what we know in order to find the derivative. So normally we take this down by a value, so it goes down 1, and then this gets multiplied by whatever was originally here. So instead of multiplying, we're essentially going to be dividing, and then instead of subtracting, we're going to be adding. So I know here that this is now going to be a 3, and then I'm going to also divide whatever this is by 3. So that's going to give me 2/3, because 2 divided by 3, that's what this goes up by, x cubed. Now before I proceed with this one, let's go ahead and take the derivative here and make sure that that works. So if I were to take the derivative, the 3 is going to go over here, it's going to get multiplied by this, so that's going to be 6/3, which is 2. And then this is going to go down a power to 2, so that does work. So remember, you're dividing by what you bring the power up to. So you're dividing by 3, because the power goes up to 3, you're bringing the power up by 1. Here, there's no x. I mean, technically there's x to the 0 power. So anytime you don't have a variable, you can put it in by putting it to the 0 power. Once again, you're going to divide the 4 by whatever you're bringing this up to, because remember, you're bringing it up by 1. So 0 plus 1 is 1, so you're dividing it by 1, which essentially doesn't do anything. And then the x is going up a power, up to 1, so it's just really 4x. And then additionally, whenever you take the antiderivative, you're always going to put in a plus c, because that will basically be a replacement for the constant that we don't know what the original constant was, kind of like what you did on the first page. And then of course you could simplify this. Alright, so this one, now normally if you were to take the derivative of something like this, you would use the product rule, but we don't have a way to do the reverse product rule when we're doing antiderivatives. So what we're going to have to do is we're going to have to get this into a polynomial in standard form by just doing FOIL. And that's going to give me x squared plus 3x plus 2. And now I can just take the antiderivative like I normally would. So, remember, this is going to go up a power, and whatever power it goes up by is going to be also dividing. So dividing by 3 is the same thing as multiplying by 1/3. So 1/3 x, and then it's going up a power. So whatever you divide by is the same thing as what the power goes up to. And remember, you can verify this by taking the derivative of this and making sure it ends up as this. This one here, we're going to go up to, it's a 1, so it's going to go up to 2, which means your 3 is also going to be divided by 2. And then anytime you have a constant, it's just going to be added an x in, and I have a better explanation for why that is in example 1. And then you have to add in the constant. And that would be your antiderivative. Now this one here, once again, we don't have any kind of rule to undo the quotient rule right now. So we're going to have to simplify this. Now I know that I can rewrite this as x to the 1/2 plus x cubed, and then each of these are over x squared. So now I can simplify this even further. Remember, this is like subtraction, 1/2 minus 2. Is negative 1.5, so negative 3/2 plus x. Okay, so remember, we're adding 1 to this. So if I add 1 to this, it's going to become negative 0.5, okay? I'm dividing by negative 0.5, so it's like this. And then my power is going to go up by 1. Remember, I'm adding 1, so that's still negative 0.5 or negative 1/2. And then for this one, it's just x. So x has a 1, so it's going to go up to 2, so it's going to be divided by 2, and it's going to go up to 2. Now over here, when I divide by a negative 1/2, that's the same thing as multiplying by 2, or negative 2. So it's really negative 2x to the negative 1/2 power, I'm just rewriting it as a fraction, plus 1/2 x squared. And then that would be it. You could differentiate this to verify. So there's no reason to get these wrong because you can differentiate to verify. And then I could rewrite this as this. To get the power to become positive, I can bring it to the denominator. 1/2 power is the same thing as the square root. Like that. And then this one here is a little bit different. So there's a few different ways we can think about it. We could also think about it like this. Now on your sheet, there's like a table of derivative rules, and it says this rule doesn't work when it's -1. Let me explain to you why that is. If I were to add 1 to this, this is going to become 0. So anytime we're dealing with something like this, as you all know, the derivative of ln is 1 over x. The derivative of ln of 1 minus 4, or sorry, x minus 4 is 1 over x minus 4. So anytime you're dealing with something 1 over something like this, it's always going to be ln of whatever that is. Now we don't have to worry about dividing by anything because the derivative of the inside of this would be 0. So nothing changes here. If you differentiate this, it becomes this. So this one's a little bit more tricky, but it's just a rule. And then don't forget your plus c. I almost did there. Did I add it on this one? Forgot it here too. So I'll forget it a lot. You got to make sure you remember it too. And remind me as well if I forget. And then with this one, we're just going to use our knowledge of derivatives of trig functions. So the derivative of cosine is normally negative sine, correct? So it's actually going to be opposite sine. So it's actually just going to be regular sine. And that's because if I take the derivative of sine, it's just going to be cosine. So you have to be careful about the signs here, and that's on your sheet. And then we know the derivative of tan is secant squared, so we're working backwards. So if I were to differentiate this, it would get me back to what this is. So that's a general rundown of how antiderivatives work.